Is it okay? Yeah. So let us start today's session with the new topic. So before we get into the topic, say this promotional content. So 23% discount they're offering on the eve of New Year on all subscriptions. Use code GATECIVIL. Subscribe as early as possible. It's only for limited time, limited period offer. 23% is very good amount of discount they are giving. Avail this, grab this opportunity. Then Unacademy also conducting mock examinations. You can enroll this. You can enroll to this examination free of cost. Use code GATECIVIL. The advantage of writing mock exam is it gives you first-hand experience of examination. You can get virtual experience of writing exam. Okay? And over and above will be given all India rank. So you can cross-check and verify where exactly you stand in the competition, and you can fine-tune your preparation according to your performance. Okay? Next, they are conducting so many tests at reasonable price. And that to 10% discount they are giving. Use code GATECIVIL. For all courses, you do have EMI options, so you can also pay on monthly basis. Okay, no cost EMI. This and all, something related to admission. Now let us start the course. So I thought of taking class morning session, but somehow I could not take the morning class. For that I am extremely sorry due to some technical reasons. So let us continue our discussion. Yesterday we completed precipitation. We studied precipitation in 3 parts. Okay. There we saw first we saw forms of precipitation. Then we saw types of precipitation, little theory. Then we saw measurement of precipitation. Then some numericals. Numericals you need to focus more. One is optimum number of gauges, right? Optimum number of rain gauges problems we saw. Second is estimation of missing data, missing rainfall data, that we saw. Then presentation of rainfall data we saw. How rainfall data presented in the form of hydrograph, right? Some numericals we saw. Some relations. In addition to that, this is the first part of precipitation. In second part of precipitation, we saw how to find mean precipitation. And third part of precipitation is frequency analysis of rainfall data. This is what we covered so far in hydrology. Okay, so this is about precipitation. Next, let us see the continuation of our discussion. Just precipitation is known, job is not over. What else is required to work out runoff component? Just input is known to you. Can you work out output? No. So what else you need to work out? Losses. Between input and output there are losses. Certain losses are there. They are called catchment losses. Those catchment losses we have to assess, we have to evaluate. So they are called abstractions of precipitation. Abstractions of precipitation means what is subtracted from precipitation to arrive at to net rainfall, or to arrive at to effective rainfall, or to arrive at to, in your language, civil engineers call it as runoff. Abstractions of precipitation. So what is to be subtracted from the precipitation value to arrive at to runoff component? So catchment losses are treated as abstractions of precipitation. So following catchment losses are considered to arrive at to net rainfall. What is that net rainfall? Net rainfall or effective rainfall or rainfall excess, or it is popularly known as runoff. So what is runoff component? Runoff is equal to rainfall minus losses. Runoff R is equal to, it is rainfall P minus losses, catchment losses, or abstractions of precipitation, rainfall losses otherwise, or you can write catchment losses, rainfall losses in a catchment. What is the rainfall losses in a catchment we have to consider? So rainfall losses in catchment, they are called abstractions of precipitation, or simply you can write catchment losses. One is called evaporation. We already discussed in the first class, water is a natural resource. It is not a factory made product. Nobody manufactures water. It is plentifully available around us. So what is our job? Find out what amount is available around you. Then draw that water from the nature. Use it. Again, used water, again we dispose back to nature. Isn't it? So it is cycle. It's cycle in the system. We call it as hydrologic cycle. Already studied, right? First class. Okay, anyway. So one is evaporation. Oh, before evaporation, one small loss is there that is also taken into account. Sometimes, most of the times we neglect because it being so small compared to other losses. But at least it suppose know the idea of that one. The first one is interception loss. Second one is evaporation. Third one is transpiration. Fourth one is evapotranspiration. And fifth one is infiltration. So today I will try to cover these four. Okay? We try to cover interception loss, evaporation, transpiration and evapotranspiration, and all the numericals related to them, because GATE is more of numerical oriented. Okay, today we try to study about these losses. in this class. So I'll be taking class up to 6:30. Okay, by 6:30 we'll close this up to evapotranspiration. We complete. We try to complete. Okay. Let us see what is first. The first one is interception loss. What is interception loss? So whenever rain occur, so we measure that rainfall information in a catchment with the help of rain gauge. So this is a ground. This is a ground in a catchment. Okay. We prepare a plain ground where rain gauge is installed. This is a rain gauge. Okay. So this is a catchment. Somewhere we install a rain gauge. Catchment receive rainfall here. Now the place where gauge is installed, it's a plain ground, straight away open to free sky. But entire catchment is not open to free sky. There are some certain trees, buildings in a catchment. So these tall objects lying above the ground intercept some portion of the rain. So that portion of the rain intercepted by tall objects lying above the ground, they straight away evaporate that water back to space without being collected on the ground. The water straight away, right, evaporating back to space without collecting on the ground is called interceptional loss. Actually, the place where gauge is installed, there is no such object, because close to gauge, right, surrounding the gauge, we don't allow any tall object such as trees or buildings. So we got enough clearance between them. The nearest tall object and gauge, the minimum distance we maintain, that is 2 times the height of the object or 30 meters, whichever is more. So we have got a clearance here. Therefore, this rain gauge comfortably collect all of the rainwater that occur in a catchment. Suppose tree is there here. Even tree intercepts some portion of rain that is not affected by the water collected by the rain gauge. But rain gauge is installed very close to tree. What happens then? Somewhere here it is installed. So rain happens with some inclination. Rain doesn't happen straight away, falling straight away vertically from atmosphere to ground. Sometimes it falls with some inclination. In such case, what happens? Gauge is installed close to tree. So the tree doesn't permit this gauge to collect rainwater properly. Then we get wrong estimation. Isn't it? So that's why a minimum clearance we maintain. The clearance, that the distance between the tall objects such as buildings or trees close to rain gauge is twice the height of the object or 30 meters, whichever is more. This height of the object is h. So the distance between rain gauge and this tall object is 2h or 30 meters, whichever is more. Suppose this tree height is 10 meters, so 2 into 10, 20 meters. 20 meters or 30 meters, whichever is more, means what? Minimum we have to maintain 30 meter distance. Suppose tree is 20 meters height, then 2 times height is 2 into 20, 40. So between 40 and 30, 40 is more. Therefore, we need to maintain a clearance of 40 meters there. So the whatever rainfall data that we get from a catchment recorded by the rain gauges, but all of the rainfall data recorded by rain gauge is not reaching the catchment. Some of the rainwater evaporating back to space without reaching the catchment, without falling on the ground. So that loss is called interceptional loss. But when compared to other losses like evaporation, transpiration, evapotranspiration and infiltration, this loss is too small to be accounted or considered. Therefore, most of the times we neglect that loss. So if it is given, we will take into account. Otherwise, we ignore that loss. Being so small compared to other losses, so we neglect that loss. Clear now? Hope that point is clear to you. Okay? So, rain intercepted by the tall objects. Lying above ground. So portion of rain intercepted, portion of rainwater intercepted by such objects evaporate back to space. So water evaporating, rainwater evaporating from the surface of such objects without being collected on the ground is known as interception loss. Just know the definition, that is more than sufficient. So rainwater evaporating from the surface of such objects without being collected on the ground is known as interception loss. See, now whenever rain occurs, suddenly, all of a sudden, when you are walking on a road, then where you take shelter first? You try to find a shade of a tree, isn't it? So that tree will give you protection for some time. After some time, what happens? Rain stops, but a tree starts leaking the water. So there is no rain outside, but the tree start leaking the water, isn't it? That means all rainwater it cannot retain. So some water reaches the ground. The water reaching the ground is not a loss. Water without reaching the ground, evaporating back to space is called loss. So this interception loss is maximum at the beginning of the storm. As storm duration increases, this interception loss exponentially decreases and attain a asymptotic value. That means what? We make a plot between interception loss versus time. So it is maximum at the beginning of the storm. As storm duration increases, it exponentially decreases and slowly it becomes zero. So slowly becoming zero is called asymptotic in nature. Asymptotic in nature means slowly that loss becomes zero. Okay? That's all. This much idea is there, more than sufficient. Understood now? So what is that loss? Diagrammatically, if we want to show you that loss, assume that this is a tree. This is a tree lying above ground. Assume tree this is, okay? This is a tree. When rain occurs, so portion of rain is intercepted by the tree, but some portion of rain, once tree become wet, what happens? From the leaves of the tree, from the stem of the tree, from the branches of the tree, water start getting into the ground, isn't it? Leaking into the ground. So water leaking into the ground is not a loss. So the water leaking from the leaves of the tree is called, right? It is called through fall. I'll draw in next page. This is called through fall because competitive exams, any kind of question they may ask or some definitions they ask. So you are ready to answer. I'll show you in the next page, okay? Interception loss is maximum at the beginning of the storm. As storm duration increases, interception loss exponentially decreases. So assume this is a ground. There is a tree or a building on a ground, which are nothing but tall objects lying above the ground. This is a ground, assume. So this is a tree. This is a tree. So when rain occurs here, what happens? Some rainwater is intercepted by this object. Some water start leaking from the leaves of the tree. This is called, the portion of water leaking from there is called through fall. Technically it is called through fall. Some water follow the branches of the tree, stem of the tree and reach the ground. This is called stem flow. This is also not a loss. Okay, ultimately it is reaching the ground. All of the rainwater intercepted by the tree, not straight away evaporating back to space. Most of it again coming back to ground. So what is that water that is evaporating back to space? When this tree get exposed to sun, when it get exposed to sun, all of the moisture retained by the leaves of the tree, stem of the tree, that water evaporates. That water evaporating from the surface of the leaves of the tree or branches of the tree or stem of the tree is called interception loss. This water evaporating from surface. Evaporation from surface of the tree or surface of the building. Similarly, buildings, you see, plastering will be there. Whenever plaster absorbs some water, right? That water absorbed by the plaster, cement plaster of a building, when that building get exposed to sun, again that water get out of the plaster. Again it evaporate back to space. That loss is called interception loss. Understood now? So we stand here. Whenever rain happens, we'll go and stand there for some time. Then what happens after some time? We start drenched in the rain. Rain water start leaking water through fall, stem flow, dropping down the ground. No? So we also start drenching down there. So therefore, all of the rain water intercepted by the tree, that will not evaporate back to space. Only portion of the rain water evaporated back to space, that is called interception loss. Fine, it is. Very good, that much idea is there more than sufficient. Then let us see one of the major losses in a catchment are evaporation loss. Let us see what is evaporation. So in a country like India, so we are living in a tropical climate zone. Tropical climate means what? We are living in a temperature zone. Temperature and warm conditions. We are living here. Therefore, most of the water evaporate. Right? Evaporation loss is a major loss. So water evaporating from the water bodies, when they get exposed to sun, it's called evaporation loss. Evaporation is nothing but, how can you define evaporation? Come on. Physics it is. I am teaching physics to you. Truly speaking, it is not engineering. Nothing is there in this. What is evaporation? Evaporation is the process by which water change its state from liquid to vapor and escape into atmosphere as a vapor. That's called evaporation. Clear now? The process by which water change its state from liquid to vapor. So who will give energy to change the state? Sun. When water bodies get exposed to sun, the water molecules in the water body, they gain energy. Once they gain energy, they start moving with very high speed. The molecules, water molecules which are on the surface of the water body, so once they start moving with very high speed, then they overcome the gravitational attraction or force of attraction caused by the other water molecules. They eject out of the water body in the form of vapor. That vapor which is ejected out of water body, that temporarily accumulate on the top of the water body. There is a thin layer exists on the top of the water body. There it accumulates. After some time what happens? That thin layer of air standing on the top of the water body is crowded with water molecules. There is no space available to accommodate any more water molecules. During that stage, that air parcel with full of water molecules in the form of vapor is said to be saturated. That saturated air parcel, once it gains enough energy, right, it exerts some energy, that's called saturation vapor pressure. Atmosphere do contain some water, moist air in the atmosphere do exert some pressure. The pressure exerted by the moist atmosphere is called actual vapor pressure. When saturation vapor pressure is more than actual vapor pressure, as we all know that always fluids move from high energy level to low energy level. So once that actual vapor pressure in the atmosphere keep on changes from time to time. Whatever is there at 4 o'clock, same vapor pressure you don't find at midnight 12 o'clock or early morning 6 o'clock. It keep on changes. But what will remain constant? Saturation vapor pressure remain always constant. So once the actual vapor pressure is lower than the saturation vapor pressure, then the saturation, that air parcel with fully saturated with water molecules that eject out of the water body, completely vacate that place and straight away reach to the higher altitudes of the atmosphere and accumulate at higher altitudes. How long it travel in atmosphere? Till the pressures are equal. So that is how the water accumulate in atmosphere. Air parcel with full of water molecules in atmosphere. In our language we call them as clouds. Cloud. You heard about no cloud? Clouds are nothing but an air parcel with full moisture. Every air parcel is not a cloud. Air parcel with full moisture is called cloud. Every cloud is essentially an air parcel with moisture. But every air parcel is not a cloud. There is a dry air parcel, there is a moist air parcel. Every moist air parcel, technically we call it as clouds. In our language we call it as clouds. It is nothing but a moist air parcel. Surrounding moist air parcel, what is there? Dry air parcel is there. Dry air parcel, no moisture is there in that. Okay? So where from it is collected, this moist air parcel? From the surface of the water bodies. Understood? From the rivers, from the sea, from the ocean, from the lake, from the pond, all surface water bodies, when they get exposed to sun, so that is how they accumulate in the atmosphere. From there they evaporate and accumulate in the atmosphere. Okay. So let us define evaporation. Evaporation is the process by which water change its state. Evaporation is the process. See now, no evaporation, there is no rainfall. This year evaporation is not there. Next year there won't be any rains at this place. So it's a continuous process. When this year more water evaporate from the ground, next year we'll get more rains. Because the total amount of water available in this planet is constant. Not one drop more available, not one drop less available. Resource is a constant. Water resource is a constant. It only cycle. Sometimes it is in the atmosphere in the form of vapor. Sometimes it is in the form of groundwater. Sometimes it is at Himalayas in the form of ice. Sometimes it is at Krishna river or Godavari river in the form of water. Isn't it? So it keep on changes its state. Evaporation is the process by which water changes its state from liquid to vapor. And diffuse into atmosphere as vapor. Diffusement and escape. Escape into atmosphere. Diffuse into atmosphere as vapor. Okay? I'll explain you. So this is a water body. This water body, so this is not a ground, this symbol for ground. Water body get exposed to sun. This is a water body. Okay? This water body get exposed to sun. Sun give energy, isn't it? Solar energy. Solar energy used by the sun, right? Heat the water molecules present. The water is made up of molecules, isn't it? A water molecule which is on the surface of the water body, a water molecule deep inside the water body, if you consider two water molecules, the water molecule deep inside the water body, it is pulled by equal force of attraction by other molecules. It is surrounded by other water molecules. When two distinct masses, when they are close to each other, what happens? There exists a van der Waals force of attraction. That force of attraction is, right, constant around the water molecule which is deep inside the water body. So this water molecule is pulled equally in all directions. Therefore, the net force acting on this water molecule is 0. In all directions it is pulled equally. Therefore, even though any amount of energy you give to this water molecule which is inside the water body, it doesn't get out of the water body. It always remain in water body. But whereas the water molecule which lie on the surface of the water body, it is pulled more in downward directions by other water molecules. But on the top there is no water molecule. What is there? Air molecules. There is not that much force of attraction between water molecule and air molecule on the top. Therefore, there is a little force of attraction. So there is a net force acting on this molecule. The net force acting on this molecule is 0. The net force acting on water molecule deep inside the water body is 0. The net force acting on the water molecule on the surface of the water body, there is a net force. So when these two molecules are given energy by sun, this also move with very high speed, this also move with very high speed. So this molecule, though it move with very high speed, water molecule which is deep inside the water body, it doesn't get out of the water body. It remain in water body only. No force can separate that molecule from the water body. But whereas a molecule which is on the surface, once it start moving with very high speed, like a aircraft, when it is moving over a runway with very high speed, what happens? Slowly it is lifted up. Exactly how aircraft is lifted up into space, because aircraft also self-weight is acting downwards. The weight of the aircraft, the passengers inside the aircraft, the baggage inside the aircraft, that is acting downward, and gravitational pull, isn't it? It has to overcome that resistance offered by the ground. To overcome that resistance offered by the ground, what it does? So it propels with very high speed on a runway. So when it propels with very high speed on runway, it overcome the resistance offered by the ground and smoothly ejected into space. Exactly same way, the water molecule which is acting on the surface of the water body behave like a aircraft on a runway. So once it starts moving with very high speed, what happens? It ejects out of the water body, but aircraft has got engine. That engine propel horizontally, but it doesn't have engine. Therefore, it just eject and remain on the top of the water body only. There is a thin layer of air. This is a layer of air. I will show you by black color. This is a thin layer of air that stand on the top of the water body. Start accommodating that water molecule which ejected out of water body. This is water body. This is water body. So water molecule ejected out of water body start temporarily accommodated where? In this air layer. So like that, one by one water molecule start accumulating in the air parcel. So once at certain stage, what happens? The total air parcel standing at the top of the water body is completely filled with water molecules. There is no space available to accommodate any more water molecules. During that stage, it is said to be saturated. The pressure exerted by the saturated air parcel is known as saturation vapor pressure. What is that? Saturation vapor pressure. Pressure exerted by saturated air parcel standing on the top of the water body. Atmosphere also do exert some pressure. So atmospheric pressure is called actual vapor pressure. So saturation vapor pressure, actual vapor pressure. When saturation vapor pressure is greater than actual vapor pressure, then evaporation starts. That means that air parcel along with that water molecule start rising vertically into higher altitudes into atmosphere. Start vertically rising up in the atmosphere. And it reaches to higher altitudes, there it accumulates there as a cloud. So this is called evaporation. Evaporation happens. Okay. So this was first noticed by whom? Dalton. Dalton was the first person to explain this phenomena to the world. So this is, so evaporation is explained by Dalton's law of evaporation. He gave an equation. So that is the basis to work out evaporation from evaporation laws. Dalton's law of evaporation. Dalton's law of evaporation, which states that rate of evaporation is proportional to the difference between saturation vapor pressure and actual vapor pressure. Rate of evaporation means what? Evaporation in a given time. How much water evaporated in 1 hour? How much water evaporated in 1 day? That's called rate of evaporation. E is proportional to the difference between saturation vapor pressure and actual vapor pressure. If you remove that proportionality you can remove by keeping one constant. So I'll keep one constant to give mathematical treatment to this. So E is equal to K into PS minus PA. So this is a basis to work out all kinds of estimations related to evaporation. Hope it is clear to you. Am I confusing you? This you have to understand too before we jump into problems, before we solve numericals. Clear or not this concept? So PS is known as what? Saturation vapor pressure. What is PA? Actual vapor pressure. Pressure exerted by the atmosphere. Okay, that's it. This is the basis. Now let us see how many methods are there to estimate evaporation loss. Methods to measure and estimate evaporation loss. Now let us see numericals. Loss, it is a loss only, Fermi loss, because I am living on the ground. Any water going away from me is a loss. Actually there is no loss, no gain. Loss to one system is gain to other system. For atmosphere it is a gain, for ground it is a loss, because we are talking about water available on the ground. Therefore, for us it is a loss, isn't it? There are 4 ways we can work it out. One is called pan measurement of evaporation. Physically we can measure pan measurement of evaporation. And second one is we have got some empirical formulae. All these formulae are based on Dalton's law only. There are some empirical formulae. Just by remembering formulae we can work out, but that is not popular technique. Very popular technique is water budget method. You can expect one question in GATE exam. Water budget method and energy balance method. So 4 methods are there. Out of these 4 methods, water budget method is very, very important. And second important one is pan measurement of evaporation. These 2 topics are important. Remaining, if you learn, well and good. Otherwise also, it doesn't make any difference. Because civil engineers, this water budget method is very popular among the civil engineers. Therefore, whichever method we are comfortable, obviously that is important for exam as well. Let us see. The first method, pan measurement of evaporation. Actually, rainfall we measure every day. So every day we measure rainfall. So I force you to measure evaporation loss also every day. So from real water bodies such as Krishna River, Godavari River, Ganga River, Kaveri River, Narmada River, every day you want to measure how much water evaporating from river to from the river body. Right? In spite of evaporating huge amount of water. Generally what happens when water evaporates, water leaves the water body. Water level in the water body increase or decrease? When loss happens, water level increase or decrease? When your bank is there, some amount is accumulated in your bank. When you withdraw money from the bank, bank balance increases or bank balance decreases? Bank balance increases or decreases? Decreases. Exactly same way. When water evaporates from water body, water level in the water body has to decrease or water level has to depress. But in spite of evaporating huge amount of water from the water body, the difference in water level in a given day in 24 hours, finding it is very, very difficult. You can't measure. There is a loss, there is a decrease in water level in the water body, but physically you cannot notice it. So it is impossible to find out that physical difference. Yesterday what is the water level? Today also it appears like a same. Isn't it? So it is very difficult. Such a large water body, in spite of evaporating huge quantity of water, yet you don't find much difference in water level. Measurable difference you can't notice. So therefore what we do is, instead of measuring the straight away water level in the water body, we install a small container. Small container is nothing but a pan. Something like a biryani handi, rice handi kind of container we install close to water body. Wherever Krishna River you want to measure, on the bank of the Krishna River you have to install that, because atmospheric condition changes from place to place. So whichever place you want to measure evaporation loss, at that place only you need to install. So near the water body you have to install. So when you install, same river water you have to put into that container. So small container, even a little water evaporates, there is a great change in water level in the container. That easily you can measure. Understood? Even small amount of water evaporates because container surface area is very small. Even little water evaporates, there is a appreciable drop in water level in the container, which you can comfortably measure by using any kind of measuring device. Scale you can use and measure it out. Isn't it? So simple. So we try to measure evaporation loss in a pan. We try to correlate that information to the actual water body. Correlation. We try to work out that correlation. Because whoever manufactured that fan, that fellow will give you correlation between actual measurement and pan measurement. So using that correlation, by knowing the pan measurement of evaporation, we try to measure actual evaporation loss from the real water body. Actually, our interest is finding evaporation loss from real water body. But because we are inefficient to measure straight away actual evaporation loss from real water body, indirectly we measure that evaporation loss from water body by measuring evaporation loss in a small container known as pan. Understood? Clear now? Pan is a container of some standard dimensions. That's all. Pan is a container of some standard dimensions. Installed. Where it is installed? adjacent to water body. Adjacent to water body, filled with water to certain level. Filled with water to a stipulated level. We fix the water level. So 1 meter depth or something according to depth of the container. Stipulated level. So by observing the what happens after filling the container with water to stipulated level, then we leave it as it is without disturbing it for 24 hours, next 24 hours. After 24 hours, we will go and then find out the water level in the container by observing the changes in water level in the container. In a given time. What is the time? Usually once in 24 hours. Pan evaporation is measured by using the following formula. Based on this formula, they will ask questions in GATE exam. So pan evaporation E is equal to any symbol you can keep. It is P plus or minus Z. That's all. What is pan evaporation? P plus or minus Z. Okay, what is this Z? Z is nothing but change in water level in the container. Then what is P? Why P has come? See now, when you are deposited some money in the bank, that money is there for 1 year. So sometimes what happens after 1 year, you see, you keep on withdrawing money in 1 month. You withdraw money, but some month they will give, for your whatever money is there, for that you will get interest also. That interest is deposited into your account, isn't it? 10,000 money is there, so you have withdrawn 500 rupees in this month, but interest paid by you by the bank is 1,000 rupees. So sometimes surprisingly you will find 10,500 in your bank account in spite of withdrawing 500 rupees from your account. You're supposed to have only 9,500 in your account, but surprisingly you will find 10,500. Who deposited that money? Extra money. Interest paid to your deposit, isn't it? It's exactly same way. During our observation, what is guarantee that there is no rainfall in 24 hours? Rain may occur in 24 hours. When rain occurs in 24 hours, what happens? That rainwater start accumulating in the pan. When rainwater start accumulating in the pan, what happens? Water level, instead of decreasing, water level in the pan sometimes increases. Therefore, we have to apply correction for that. That correction is called P. Okay? So, pan evaporation E is equal to P plus or minus Z. What is P? Rainfall during the period of observation. P is equal to rainfall during the period of observation. Rainfall in 24 hours. Because evaporation we measure in 24 hours, rainfall also we measure in 24 hours. Right? What is Z? What is Z? Come on. Change in water level in the pan. Change in water level in the pan. Right? So how to find Z value? Z is equal to, so volume of water or depth of change in water level in the pan. Okay, no issue. Volume of water added to pan or removed from pan. Pan by surface area of pan. Volume by area is equal to depth because it is a depth unit. So therefore, in terms of depth, we need to get. So what is this plus or minus symbol? So when water is added to pan, right? When water is added to pan in the form of rain, water level increases. When water level increases, correction is negative. When water level decreases, correction is positive. Suppose, for example, 1 minute. Okay? Suppose you have got a pan. Some square pan or circular pan, whatever it may be. Pan is there. Right? You filled pan. Before observation, water level in the pan is at 1 for example. Okay. Then due to evaporation, water level increases or decreases? It has to drop down. So assuming that on that day when you measure that evaporation loss, there is no rainfall, no rain has occurred. So rainfall is equal to 0. That is P is equal to 0. No rain has occurred. Water level decreases. So decrease in water level is called Z. Okay. At the end of the day, what we do? We go there and we add water to the pan, because again we need to continue our observation. Again tomorrow's evaporation loss I need to measure. Therefore what I need to do? To bring back water level from 22 to 11, I pour water into pan and I record that value. So volume of water added to pan. This is added. No, why added to pan? To bring, because water level has depressed. So to maintain water level at 11, so I force it to add some water to pan. Okay. So I know only that volume of water added to pan. What is Z? Depth of water added to pan. So therefore on that particular day, so what is this evaporation loss? Because of evaporation, water level would have depressed. So that means though there is no rainfall, still rainfall is 0 on that day. Therefore on that day evaporation loss is equal to what? Z only. What is Z? Volume of water added to pan by surface area of pan. But next day what happens? Heavy rainfall occurs. So because of heavy rainfall, what happens? The water level in the pan rises above 11. So more rain has occurred, less evaporation. More rainfall, less evaporation. Then what happens? Water level increase or decrease in the pan? Water level increase or decrease? If only evaporation occurs, water level decreases. And because of heavy rain, finally water level has settled at 3.3. So at the end of the day, I go to the pan and to my surprise, I found water level above 11. But to continue our observation for next day, what I need to do? We have to remove water from the pan. Right? To brought back water level, heavy rain occurred, so I removed water from the pan. So volume of water removed on that day. Volume of water removed from the pan. Depth of water removed on the pan from the pan is equal to how much it is? Z. This is a change in water level from 11 to 3.3. So what is this effect? If only evaporation occurred, water level would have depressed to 2.2. Because of heavy rainfall, finally water level has settled at 3.3. Therefore what I need? Evaporation loss on that day. Evaporation loss E is equal to P minus Z. So whenever water is removed from the pan, so correction is negative. Whenever water is added to the pan, correction is positive. Some other day you measure, instead of rising water level above 3.3, but water level is settled between 11 and 3.3. That means there is more evaporation, less rainfall. Then water level finally settled between 11 and 3.3. Suppose somewhere here it settled. So if evaporation occur, only evaporation occur, water would have depressed to 2.2, and because of rainfall finally it has settled at 3.3. Understood? So now 3.3 is below 1.1. So this is effect of rainfall. What is this effect of rainfall? At the end of the day, if I go there, then I found that water level has depressed. Z amount is depressed. So again I force to add water to the pan to bring back water level from 3.3 to 1.1. So water added to pan on that day. So when we add water to the pan, what happens? Depth of water added to pan is equal to how much? Z. On particular day, evaporation loss is equal to how much? Evaporation, I require this P plus Z. So whenever water is added, addition is, correction is positive. Whenever water is removed, correction is negative. That much idea is there, more than sufficient. So what is that Z value? Volume of water added or removed from the pan by surface area of the pan. Therefore, this Z is equal to positive when water is added to pan. Z is negative when water removed from pan. What is Z? Depth of water added or depth of water removed from the pan. Understood? Changes in water level in the pan, nothing but depth of water added or removed. Understood? That is changes in water level. So P is equal to rainfall I wrote. So when rainfall is equal to 0, when P becomes 0, when there is no rainfall. P is equal to 0 when there is no rainfall in 24 hours during the period of observation. In 24 hours no rain occur, then P is taken as 0. Any rain is there, they will give you that value. That's it. This much idea is there, you can measure pan evaporation. Okay, pan evaporation is equal to P plus or minus Z. But our interest is not finding pan evaporation. Our interest is what? Finding actual evaporation from real water body. How to find out actual evaporation from real water body? So actual evaporation loss. Actual water evaporated from water body. Actual evaporation loss from water body, such as river, lake, pond, reservoir, canal, whatever it may be, is equal to, it is Cp into pan evaporation. So pan evaporation, if you multiply with value Cp, then you will get actual evaporation. What is that Cp? Coefficient of pan. So whoever manufactured that fan, that fellow will give you correlation between actual measurement and pan measurement. Coefficient of pan or pan coefficient otherwise. Okay? So this is how we can work out. But this is in terms of depth. Sometimes we force you to measure in terms of volume also. So how to find out depth quantity into volume? How to find out depth into volume? Depth into area will give volume. Pan evaporation also in terms of depth. Therefore actual evaporation also we get in terms of depth. So volume of water loss due to evaporation from water bodies is equal to volume of water loss due to evaporation from real water bodies. What to do? What to do? Surface area of the pan into surface area of the water body, because it is evaporating from surface only. So actual evaporation into surface area of water body or plan area of water body. So you multiply, you will get volume of water loss due to evaporation. Understood? So based on this, they may ask one question in GATE exam. So you should be ready to answer. Clear? So now, these three equations you have to remember. One is pan evaporation, actual evaporation, volume of water loss due to evaporation from real water body. Okay? Now I'll give you different types of pans we use for measurement of evaporation loss. These pans also called evaporimeters, because they measure evaporation, we call them as evaporimeters. Rainfall measurement devices are called rain gauges. How they are called rain gauges? These are called evaporation gauges. We call them as technically evaporimeters. Pans are also known as evaporimeters. Okay? So very popular among all of them is US WB Class A pan. United States Weather Bureau Class A pan. So whenever we use US WB Class A pan, CP value is taken as 0.7. So we have got our own standard pan. This is called IS Class A pan. Indian Standard Class A pan, and CP value for this is 0.8. Similarly, we also have got Colorado's sunken pan, and whose CP value is equal to 0.78. We also have got USGS, United States Geological Survey floating pan. All these three are ground based pans, but this is water. It is installed in the water body only, floating pan. It floats in water. So its value is equal to 0.8. That's it. So sometimes in IS exam, IS Class A pan is used. That's how they mention. So they don't give CP value. Then in such case, by default, you can take CP value as 0.8. Understood? That's all. This much idea is there, more than sufficient. Let us work out few numericals. Patafat Dhanadhan. Then we'll get some idea regarding this, how to work out actual evaporation loss from pans under real water bodies especially. Our idea is working out from real water bodies only. Okay? Let us see. Few numericals, let us work out. Where up to now? Okay? Let us see the first question. First example. Example 1. What is the evaporation? What is pan evaporation if 4.2 liters of water is removed from an evaporation pan of diameter 1.22 meters and simultaneous rainfall measurement is 8.75 mm. Understood? That's all. So what is given to you? P is given. P in 24 hours is 8.75 mm. Okay? Let it be in mm only, no issue. So what is given? Indirectly, volume of water removed is given. So volume of water removed from the pan is given as, how many liters are removed? 4.2 liters. 1 liter is equal to, 1 meter cube is equal to 1000 liters. Okay? Therefore, I will convert this into meter cube. How many meter cube of water is removed? 1 liter is equal to how many meter cube? 1 by 1000 meter cube. So, which is equal to 4.2 by 1000 meter cube. So, 4.2 into 10 power minus 3 meter cube. Okay? Then depth of water removed is equal to, that is called Z. Z is equal to depth of water removed. Since water is removed, Z is negative or positive? Negative or positive? Negative it is. Water is added? Positive. Water is removed? Negative. I wrote here. Water added to pan? Positive. Water removed from the pan? Negative. Okay? So Z is equal to what? How to calculate? Volume of water removed by surface area of pan or plan area of pan. So he has given diameter. Diameter means it is a circle. Okay, what is circle area? Pi by 4 d square. So volume of water removed is 4.2 into 10 power minus 3 meter cube by pi by 4 d square. D is given as, diameter of the pan is given as, diameter of pan D is given as 1.22 meters. That means it is a circular pan. They could be circular, they could be square, there could be rectangle, any shape, no issue. They will give you details. 4.2 into 1.22 meters, no? 1.22 square. So meter cube by meter square, you will get answer in meters. Come on, work out. I need answer. Come on, give me. So 4.2 into 10 to the power minus 3 by pi by 4 into 1.22 square. So I got 0.00359 and 3.59 into 10 power minus 3. How much I got? 3.59 into 10 power minus 3. What is unit? Meters. That means how many mm? Multiply with 1000. Multiply with 1000, meters converted into mm. So it is 3.59 mm. Okay? Z I got. Therefore, pan evaporation is equal to, pan evaporation E is equal to P plus or minus Z. In this case, plus Z or minus Z? Minus Z. Z is negative since water is removed. Whenever water is removed, negative. Whenever water added, positive. Therefore, P is given in the question. What is P value? 8.75 minus 3.59. 8.75 minus 3.59. How much it is? Both of them are in mm only. So, comfortably you can subtract. 8.75 minus 3.59. So, it is 5.16 mm. So that was the answer for this question. Understood? That's all. He is asking only that pan evaporation. Any confusion is there? Any confusion is there? You can type there. If any doubt is there, you can type in the comment box. Okay, let us take one more question, variety of question. Example 2. .75 liters of water is added to an evaporation pan of 1.2 meters diameter to bring the water to a stipulated level. Stipulated level means what? Fixed level. If nearby rain gauge or rain gauge, some people call gauge also, rain gauge, measure a rainfall of 4.2 mm. In that time period, rainfall, how much amount of rain has occurred? 4.2 mm. What is pan evaporation? What is actual evaporation? What is pan evaporation? And what is actual evaporation from real water body? Come on. What is given to you? Volume of water added is given. How much is given? Added to pan. Given as 8.75 liters. How many meter cube? 8.75 into 10 power minus 3 meter cube. Okay? Diameter of pan is given 1.2 meters. Therefore, depth of water added to pan. What is the depth of water added to pan? Z. Z value. How to calculate Z value? Volume of water added to pan by surface area of pan. So it is Z is equal to 8.75 into 10 power minus 3. Circular pan again, diameter is given means pi by 4 into 1.2 square. Come on, work out. So it is 8.75 into 10 power minus 3 into 4 by pi into 1.2 square. So I got 7.736 mm into 1000. Straight away I am converting into mm. Actually it is 7.736 into 10 power minus 3 meters, which is nothing but 7.736 mm. Okay, this we got. So therefore pan evaporation is what? Pan evaporation is equal to P plus or minus Z, but in this case it is plus Z or minus Z? Plus Z. Why? Z is positive since water added to pan. So therefore P is given in the question. Rainfall during that period is how much is given? 4.2 mm. And Cp also given. And Cp is given as point. Cp is given in the question. If Cp is equal to 0.7, he has given 0.7. Okay, P plus or minus Z. So P is given as 4.2 mm plus 7.736. It is 11.936 mm. That is the answer for first question. Second question, what have been expected extra actual evaporation? actual evaporation from real water body is equal to, it is Cp into pan evaporation. So Cp is given as 0.7, pan evaporation is given as 11, we calculated 11.936. So 0.7 into 11.936. It is 8.355 or 356 otherwise. 3552, I rounded to 356, okay? That was the answer for this question. If you have any doubt, you can ask me. Come on. Doubts are there, you can ask me. No doubt? I'll go to empirical formula, no need to remember this. This is how we can work out pan evaporation. So that is technique, okay? Sometimes they'll ask volume also, but volume, they ask volume of water evaporated, this you have to multiply with surface area of water body. Surface area of water body is given to you, then you can find out volume of water loss due to evaporation. Let us work out one problem, ESC question. Example 3. This is asked in ESC exam. Without calculator you can manage. A standard ground based evaporation pan corresponding to Indian standard. Indian standard means what? IS pan. IS pan Cp is how much? 0.8 is installed. So indirectly given Cp value at the banks of a surface reservoir. The water surface on a particular day is water surface, simple only, on a particular day is 100 hectares. The recorded evaporation loss. So evaporation loss straight away given. Recorded evaporation loss from the pan on a certain day is nearly 4 centimeters. Evaporation loss from the pan on a certain day. Nearly 4 centimeter. What is anticipated evaporation loss from the reservoir for the day? So this question has been asked in ESC exam 2007. So options given are, it is 1.8 to 2, he has given like this, into 10 power 4 meter cube per day. Ranges are given because without calculator you have to work out, or 2.5 to 2.75 into 10 power 4 meter cube per day. C option is 3 to 3.25 into 10 power 4 meter cube per day. D is 3.8 to 4.05 into 10 power 4 meter cube per day. So one option is right option. What is the right option? You have to find out. So what is given to you? Pan evaporation is given straight away. So earlier we worked out pan evaporation also using equation P plus or minus Z. But P plus or minus Z value straight away given here. Pan evaporation from reservoir is equal, pan evaporation installed at reservoir is 4 centimeter in a particular day. So CP value is given as not given, but it is taken as 0.8 since it is IS span. For IS span CP value is how much? 0.8. Indirectly given this is. Okay. So therefore actual evaporation from reservoir on that day is equal to actual evaporation loss from reservoir is equal to on that day is equal to Cp into pan evaporation on that day. So Cp value is 0.8, pan evaporation is 4 centimeter, so which is equal to 3.2 centimeter. Okay. Then anticipated evaporation loss. Anticipated evaporation loss from reservoir, nothing but volume of water evaporated from reservoir. Volume evaporated from reservoir. Come on out, find out. So depth of water evaporated from reservoir into surface area of reservoir. Actual evaporation from reservoir into surface area of reservoir. So actual evaporation loss from reservoir is how much? Already we got 3.2 centimeters. This I am converting into meters. Surface area of reservoir is 100 hectares. Hectares converting into meter square. 1 hectare is equal to 10 power 4 meter square. So this is in meter square, this in meters. Then we will get answer in meter cube. Therefore answer is 3.2. 100 get cancelled. Then you will left with 3.2 into 10 power 4 meter cube per day on that day. So the answer is 3.2 into 10 power 4. So which range it is matching here? 3.2 into 10 power 4. In this C is the correct option. This is the answer. 3 to 3.25 is given. So it is 3.2 I got. So the range is here. Understood? 2 marks question in GATE. This is ESA exam. This is. Any confusion is there? So I took one ESC question also. GATE questions, ESC questions, everything there. Then empirical formulae, nothing is there to remember, nothing is, they are not so important. I list out some of them, but not required for you also. All these empirical formulae are based on Dalton's law of evaporation. So nobody will ask you, you need not worry. So first formula is, it's called Fitzgerald equation. So all of them formulae are derived from Dalton's only, of course, based on Dalton's only. So rate of evaporation, straight away Fitzgerald equation will give rate of evaporation in mm per day. Mm per day is equal to, it is 0.4 plus 0.124 V into PS minus PA. So Dalton's law of evaporation if you see, E is equal to K into PS minus PA. This is K value actually, truly speaking. So they have given different kind of approaches to find out that K value. So in this equation, K value is this one, 0.4 plus 0.124 V. Similarly, Meade's equation or Meade's formula. This is straight away will give evaporation loss per month. Meade's formula. So rate of evaporation. So like this, so many formula are available. You can use them. Almost half dozen formulas are there. And in the Meade's formula, we'll get evaporation loss straight away in say mm per month. Sorry, mm per month we'll get. So rate of evaporation loss is equal to, it is 1 plus 0.6215 V into C into PS minus PA. In all these equations, V, PS minus PA carry same meaning. Extra thing here is Meade's constant C. Okay. Similarly, so many formula are there. Ruert's formula is there, right? Half dozen formulas are there, but not required. You can ignore this. So in this equation, PS and PA carry. PS and PA are saturation and actual vapor pressures. Because empirical formula, I know units are important, expressed in mm of Hg, millimeter of mercury, whereas the V is known as wind speed. Wind speed we measure in kilometers per hour, kmph, kilometers per hour. If you substitute, then you will get answers. Okay, not required. So many formulas are there, no need to remember, ignore. Then very important question that asking approach to work out this evaporation loss, which frequently they are asking in exam, is water budget method. Okay, water budget method is very popular. Budgeting is very common. So everywhere we carry out this budgeting method. Indian government also prepare budget for the nation, country, once in every year, and they submit that budget in the parliament, isn't it? Finance minister submit that budget. Similarly, state government also prepare budget and they submit and disclose to the public in assembly. Similarly, your parents also prepare budget every month. Budgeting is nothing but what is income, what is expenditure. How much money I am getting, how much money I am earning in a month, what is my expenses in a month, how much money I have to spend, how much money left at the end of the month, how much I can keep in the bank. This is called budgeting. Exactly same way, around water body, if you write water budget equation, so around water body sometimes collect water, sometimes water get out of the water body. Some water is used from water body, some water it accumulate in the water body, isn't it? Sometimes the inflow into water body is more than outflow. Sometimes outflow is more than inflow, isn't it? Bank balance, some 1,000 rupees is there. This month 5,000 you deposit. Then what happens? Bank balance increase or decrease? Increases. Next month you don't deposit anything, but 500 extra you withdraw. At the end of the month, bank balance decreases. So exactly using that approach, we can also work out evaporation loss. This evaporation loss is based on law of conservation of mass. Mass neither be created nor destroyed. So based on that we work out by writing water budget equation around a water body. So this method is based on law of conservation of mass. What is the law of conservation of mass? Mass neither be created nor destroyed. So by writing water budget equation around the water body, in a given time, that is also important. Evaporation loss from water body is estimated. Evaporation loss from water body. One can estimate evaporation loss from water body. So I'll show you. Clear? So this is a big water body. Could be a river. For example, assume it's a river. So this river receives some inflows. River water we also use. Right? Rain occur on over a ground. That rainwater where it go? Finally go and join in the river only. Okay? Rainwater joining from the ground into ground is nothing but a catchment. So water from catchment join the river, water body. So water joining the water body is inflow or outflow? Inflow or outflow? Inflow. So like that there are so many inflows into water body. I take it as sigma inflows. Similarly, we use water for drinking purpose, we use water for irrigation purpose, we use water for different purpose, industrial purpose. We draw that water from river only. So water is drawn from river, again water in the river decreases. Similarly, evaporation also occur naturally and artificially, both of them taken into account. So before our observation, water level in the water body is at 1,1. Let us assume the initial water level in the water body before we carry out observation. Before our carry out observation in the January month, for example, January month we are. So before January 1st, water level in the water body is at 1,1. So in the January month, inflow is so and so. In January month, outflow is so and so. Sometimes inflows are more, outflows are less. Sometimes outflow is more, inflow is less. So because depending upon how much amount of inflow joins the water body, how much amount of water drawn from the water body, right? Water level in the water body changes. Initial level is definitely at 1,1. Sometimes water level rise above 1,1. Sometimes water level fall below 1,1. So if water level rise above 1,1, storage in the water body increase or decrease? Storage increase or decrease? Water level rise. When rises? When inflow is more than outflow, water level rises. So that's called change in storage. Right? Delta S is nothing but change in storage. Similarly, this is also delta S. So when it rises above 1,1, it is called positive change. When it falls below 1,1, it is negative change. Change is negative. Delta S is taken as positive sometimes. Delta S is taken as negative sometimes. When it is taken as negative, when water level fall below 1,1, then it is taken as negative delta S. So I'll write that water budget equation. What is that water budget equation? Sigma inflow minus sigma outflow is equal to plus or minus delta S. So delta S is nothing but change in storage in water body. Changes in storage. So delta S is positive when water level rise above 1,1. Water level rise above 1,1. Delta S is negative, water level fall below 1,1. Water level increases, positive. Water level decreases, negative. Negative when water level fall below 1,1. Okay? When water level fall below 1,1, it is taken as negative. When water level rise above 1,1, it is taken as positive. Okay? So, what are the possible inflows? What are the inflows? Rain that occur over a water body, inflow or outflow? Water join the river or water leave the river? Whenever rain occur on the river surface. Join, no? So that therefore it is inflow. Rainfall is taken as inflow. Similarly, the runoff join the water body. Water collecting from the ground and joining the water body, inflow or outflow? The runoff collected from water body is called runoff. Water collected from ground is called runoff. So runoff is inflow or outflow? Inflow. Similarly, the water evaporates from water body. Some water evaporates, no? Water evaporates from water body is inflow or outflow? Evaporation loss. Water leave the water body, outflow or inflow? Outflow. Right? So therefore evaporation is taken as outflow. Similarly, some water soak into ground also. From the ground also it soak. Seepage loss it is called. Inflow or outflow, this is seepage. Water is leaving the water body or getting into water body? Leaving the water body. So therefore this is also outflow. Similarly, the water used for different purposes is inflow or outflow? Outflow. Outflow. So that's all. So what are the possible inflows? Only two are there. So sigma inflow is equal to, it is runoff R, okay, rainfall P plus runoff R. Rainfall P plus runoff R. Therefore, sigma inflow is equal to, we write shortcut, it is P plus R. Similarly, sigma outflow is equal to water leave the water body. So water used O plus evaporation E plus seepage. Yes. Arrows leaving the water body is outflow. Arrows getting into water body is inflow. This is getting into or leaving. Arrow getting into water body, inflow. This getting into water body, inflow. Leaving the water body, arrows, they are outflow. Arrows leaving the water body is outflow, arrows getting into water body is inflow. Understood? So sigma outflow is equal to what? It is O plus E plus S. So if you write complete water budget equation around the water body, therefore, what is that? Sigma inflow minus sigma outflow is equal to plus or minus delta S. Sigma inflow is, it is P plus R. What is sigma outflow? O plus E plus S is equal to plus or minus delta S. So in this equation, anyone could be unknown. Based on this, they are keep on asking questions in GATE exam. In this equation, sometimes runoff is unknown, sometimes evaporation is unknown, sometimes seepage is unknown, sometimes water used is unknown, sometimes rainfall is unknown, sometimes change in storage is unknown. Anyone could be unknown. Remaining things should be given to you. Then you can work out. So while substituting things in this equation, all these terms either you can substitute in terms of depth, or you can substitute in terms of volume, or you can substitute in terms of flow rate also. So that point you need to remember. This changes happens in a given time t. In a time t, all these changes we noticed. In a given time t, delta t, we noticed all these changes. Okay? So that is also important. Clear now? Shall we go ahead with solving problems? Are you ready? Okay. So from this topic only they are asking questions in GATE exam. Water budget method is very popular. Let us try one question. Example 4. The plan area of a reservoir is 1 kilometer square. The water level in the reservoir is observed to decline. Decline means what? Water level is increasing or decreasing? Decline means water level is falling, decreasing. Decline by 20 centimeter in a certain period. During this period, the reservoir receives a surface inflow of during this period, the reservoir receives a surface inflow of 10 hectometers. Hectometer is a unit for volume. Hectare meters. Okay? And 20 hectometers are abstracted. Abstracted means water used. Water is removed, taken from the water body. Okay, from reservoir. Abstracted from reservoir. For irrigation and power. For irrigation and power. Hydropower, no, hydropower is hydropower. How hydropower you get? By using water only. Electricity. The pan evaporation and rainfall recorded. Pan evaporation is given, but what require actual evaporation is required from reservoir. The pan evaporation and rainfall recorded during the same period at a nearby. See now, this question is this much big, lengthy, but answer is one line only. At a nearby meteorological station. meteorological station are 12 centimeters and 3 centimeters respectively. The calibrated pan factor. What is that calibrated pan factor? CP value 0.7. The seepage loss from the reservoir during this period in hectometer. So he has given answer 0, B 1, C 2.4, D 4.6. So 1 is the correct answer. One option is the correct answer. So we have to find out what is that option. So what is given in the question? Plan area of reservoir is given. So surface area of reservoir is given as surface area, plan area, both of them are 1 and same. 1 kilometer square. But you've been asked to work out in hectometer. 1 kilometer square is equal to 10 power 4 hectares. So area is equal to 10 power 4 hectares. Okay, that's given. Water level has declined. So this is a water body. The actual level of water in water body is somewhere here, this 1, but it has declined, decreased by 20 centimeter. So water level has increased or decreased? Decreased. How much decreased? 20 centimeter. So delta S is positive or negative? Negative, since water level has decreased. So whenever water level decreases, negative, water level increases, positive. If it rise above 1, positive. It fall below 1, negative. Understood? So in this month, pan evaporation is given. So water is evaporating here. So actual evaporation you can find out from pan evaporation. In this month, the water joining is given as 10 hectometer. Water leaving is given as 20 hectometer. This is inflow I. This is outflow O. Then what else is given? Rainfall also given in that month. So rainfall in that month is equal to, this is P. That is also given to you. So you have been asked to find out what? Seepage loss. Just 1 minute, please. Sir, class lo, I am in class. I'll call you after half an hour. Okay, sorry. Okay? Seepage loss you have to find out. Come on, work out now. So I is given as 10 hectometer. O is given as 20 hectometer. You have been asked to find out seepage loss also in hectometer. Let us work out remaining things also in hectometer. What is given? Precipitation is given. Decline by 20 centimeter. Delta S is given. So delta S is given as 20 centimeter. Okay. But let us convert all of them into same unit system, hectometer. Rainfall is given 3 centimeter. And pan evaporation is given as, how much is given pan evaporation? 12 centimeter. But Cp of the pan is given as 0.7. Therefore, actual evaporation is equal to E. Actual evaporation only you have to take. E is equal to Cp into pan evaporation. See now last concept still we are using here. So 0.7 into 12 it is 8.4 centimeter. So I have got E, I have got P, I have got O, I have got I have got delta S. The only unknown is S, I can find out. So but these parameters you need to work out in hectometer. How to find depth into hectometers? Depth quantity, how to convert into volume quantity? So volume in hectometer is equal to, volume in hectometer is equal to surface area in hectares into, or plan area in hectares into plan area of reservoir. Reservoir, this is okay, reservoir in hectares into then depth of that quantity. This you substitute in meters. Okay, how to convert this into meters? Centimeters to meters how to convert, because all of them is given centimeters. Let us work out now. I am writing water budget equation. What is the water budget equation? Sigma I minus sigma O is equal to, it is plus or minus delta S. What is I? P plus R or P plus I, whatever it may be. I took it as I, no? Inflow. Okay, I took it as I. Okay, you can put a runoff, runfall, whatever it may be. I or R, whatever it may be. Okay, minus O plus E plus S is equal to plus or minus delta S. But in this question, P is equal to, given in the question, 3 centimeters. But 3 centimeters I am converting into meters. But you have to convert this depth quantity into volume quantity by multiplying with the plan area of reservoir. What is plan area of reservoir? 10 power 4 hectares. So I will multiply this with 10 power 4. So this is hectares, this is in meters. So this total quantity is in which unit system? Hectometer. So I substituted P in hectometer plus R. That is given already in hectometers, 10 hectometers. Okay, minus O. That is also given already in hectometers, 20. Plus E. Actual evaporation is 8.4 centimeter. Again it is in depth unit. How to convert depth unit into volume unit in hectometers? 8.4 by 100. Now it is in meters into 10 power 4 hectares. Then this become hectometer. Plus CPS is unknown is equal to plus delta S minus delta S minus delta S. Why delta S is negative? Since water level has declined. So in this case delta S is taken as negative. Why negative? Since water level has decreased. Since negative sign, delta S is negative. Since water level has decreased. Okay. If water level increases, we take it as positive. How much it is? 20 centimeter. This also you have to convert into hectometer. 20 centimeter to convert into meter by 100. Multiply this with 100 again to convert into hectometer. So it is 3 by 100 into 10 power 4. What is this value? P plus this value is R. P plus R minus O. O is 20 hectometer plus 8.5 by 4 by 100 into 10 power 4 plus S is unknown is equal to 20 by 100 into 10 power 4. So meter into hectares, hectometer. So this is P, this is P, this is R, this is O, this is E, this is S, this is delta S. All substituted. Understood? Oh, 1 kilometer square is equal to how much it is? Oh, sorry. 1 kilometer square is equal to 100 hectares, not 10 power. 1 hectare is equal to 10 power 4 meters square. 1 kilometer square is equal to 100 hectares. Sorry. So it is multiplied with 100. 100 hectares. 100. See, now you should be careful regarding the units. You are little complacent, you will go wrong. See, now I am little complacent, I have gone wrong. Minus, no, this is minus. That is also important. Minus 20 by 100 into 100. This is also 100. Now let us see how to simplify. If we simplify 100 cancel, 100 cancel, 100 cancel. Simple it is. So 3 plus 10 minus 20 plus 8.4 plus S is equal to minus 20. This minus is there. That is very, very important. Come on, simplify now. How much you are getting? 13. This 13 will go to that side. So this become minus 20 plus 13 is 33. 33 minus 28.4. So it is 33 minus 28.4. How much it is? 4.6. So S is equal to 4.6 hectometer. That was the answer for this question. Let us verify, cross check with the given options. 4.6 is there or not? 100% will find. That was the answer. 2 marks question, GATE exam this is. So this is how we need to work out in the exam if they ask questions from there. So let us take up last approach, that is energy balance method. Where it has gone? Solution. There is solution. It is cancelled, huh? Why it has come all of a sudden? Okay? Clear now? Hope this concept is clear to you. Now, exactly same way, energy balance method. This energy balance method is based on law of conservation of energy. Energy neither be created nor destroyed. So by writing energy balance equation, around water body, evaporation loss is estimated. This is little difficult approach for civil engineer. The reason being, we are not so comfortable with the thermodynamic terms. So this is a water body, right? Having water. This water body exposed to sun. So solar energy is energy in into water body. What is energy out from water body? Water used in evaporation loss, energy absorbed by the ground, and as well as the energy given to rising the temperature of air parcel lying above the water body. So there is some energy in. What is this? Energy in into water body. This is called sun give energy to water body. Sun is the chief source of all energy over this planet. So complete energy we are getting from sun only. That energy we harness for different purposes. This energy in into water body. Okay? Otherwise I will write. This is called HE. Or, okay? Insulation, incoming solar radiation, that is I. I'll take it as I. Okay, I'll put red letters, okay? Energy received by the water body is I. So some energy absorbed by the ground. The energy absorbed by the ground is called ground heat flux, that is HEC. Some energy is used in heating the air layer standing on the top of the water body. That is called sensible heat loss to atmosphere. Isn't it? When you are drinking coffee or tea, right, whatever heat energy it gained after boiling the coffee or tea using a gas stove or something like that, after 10 minutes you see what happens to energy levels, increase or decrease? Decreases. Because how it decreases? Some heat energy escape into air. So say exactly same way water body also. So that is called sensible heat loss to atmosphere. That is called HA. What is that? HA. Sensible heat loss to atmosphere. This is HC. Energy absorbed by the ground. So energy flow into ground, that is. Remaining energy used in evaporating the water molecules. So energy used in evaporating water molecules is He. So arrows getting into water body is in, arrows leaving the water body is out. Energy neither be created nor destroyed, or it can't be stored also. Therefore energy in must be equal to energy out. So that's called energy balance equation. So energy in into water body is equal to energy out, or energy in minus energy out is equal to 0, because energy neither be created nor destroyed nor it can be stored. Energy in is equal to energy out. What is energy in? I. What is energy out? What is energy out? See here, three things: HA, HG and HE. HA plus HE plus HG. What you are looking for? HE, energy used in evaporating the water molecules. So I minus HA plus HG. Okay, this HE, I is called, this I is known as incoming solar radiation. That's called insulation. That is energy in into water body. We call it as technically insulation, incoming solar radiation. What is HA? Sensible heat loss to atmosphere. Sensible heat means what? Right? That heat energy which doesn't change state of the matter. State of the matter is not changed, it is called sensible heat. State of the matter changes, it is called latent heat. Right? Suppose we get fever. When you get a fever, what happens? Temperature of your body increases. Only temperature increases, but we don't change our state. Physical state remains same. But whereas in case of water, when you boil the water, temperature increases, what happens? Water molecules escape. That is called latent heat. Latent heat is different, sensible heat is different. Latent heat means change the state. Liquid to vapor it convert. Liquid to vapor, change the state. But we don't convert into vapor. We don't convert into gas. We don't convert into liquid. Even if we body gain the temperature, that is called sensible heat loss. Sensible heat loss to atmosphere. Where HC is equal to ground heat flux. That is energy flow into ground. Ground heat flux. Then what is HE? Energy used in evaporation. Energy used in evaporation of water molecules. So this energy used in evaporation of water molecule we calculate by HE is equal to, we calculate this using by one equation. This HE is equal to rho W into L into E. Rho W into L into E. Okay, I'll put capital E only. So this rho W is known as density of water. L is known as latent heat of vaporization, because it changes state, no? Therefore it is called latent heat. Latent heat of vaporization is rate of evaporation. Rate of what we are looking for? Evaporation loss. Therefore this equation He is equal to I minus HA plus HG. In this equation I am substituting this HE value. If you substitute HE value rho W into L into E, then you can calculate that evaporation loss E, possibly, indirectly. So rho W into L into E is equal to I minus HA plus HC. Therefore we are looking for what? E. Therefore E is equal to, it is I minus HA plus HC by rho W into L. That was the equation. So this equation is evaporation loss is equal to, it is I minus HA plus HC by rho W into L. So this is exact calculation, but HA and HC being so small compared to I, therefore most of the times it is neglected. IR or radiation or solar radiation, otherwise you can put R also. I'll put R, that is better word. Radiation, no, this is incoming solar radiation. I'll put R because textbooks they take R. Any symbol doesn't matter here. You can use any symbol. So I'll put textbook values only, R value. So let us take it as R. Okay? I also can use, nothing wrong in that. Meaning is important. It doesn't make any difference. Our understanding is important. So finally, we got one expression. R minus. So since HA and HC being so small, they are neglected most of the times. Since HA and HC being so small amounts compared to R and L. So small. Therefore, they are neglected. Neglected means what? When they are taken as 0. HA is equal to, HG is taken as 0. If you take HA 0, then this equation become very simple form. E is equal to R by rho W into L. So most of the times, if at all they ask any question, so you are expected to take HA and HG as 0. Otherwise, it becomes so complex procedure. So that much complexity no need to invite because the quantities are very, very less. So this R is measured, incoming solar radiation we measure in kilojoules, joules per kilograms. Sorry, joules per kilograms. This unit is joules per kilograms. Rho W value we substitute in kilogram per meter cube. Latent heat of vaporization we substitute in latent heat of vaporization. Oh, this is R. R is latent heat of vaporization. This is substituted in watts. So and so watts, kilogram per meter cube. This is joules per kilogram. Then straight away will get E value in meters per second. So this unit system not remember because we are not so comfortable with thermodynamic terms. That's why it is not so popular among the civil engineers. But civil engineers mechanical engineers working with the civil department, they are very comfortable with thermodynamics. So there is their approach. This is therefore it is not as so popular among the civil engineers. Water budget method is very popular among the civil engineers. If at all they ask any question from this topic, it is from water budget method only. You can ignore this. So that empirical formula and this approach you can ignore, but remaining are very, very important. So that's what for today's class. So I completed almost 2 hours time. So we revised the content. Very important. This water budget method is very, very important for exam. Frequently they are asking questions from water budget method. Okay, be clear. Empirical formula you can ignore. Evapotranspiration tomorrow we'll discuss. So tomorrow I'll take same time class 4 o'clock to 6 o'clock or 4 o'clock to 6 o'clock. Tomorrow I'll take class. Okay, or not 4 o'clock to 6 o'clock. 2:30 to 4. I'll take 2:30 to 4:30. I'll take class tomorrow. So in that class I try to cover evaporation, transpiration, evapotranspiration and as well as infiltration. I'll start. Then we'll try to finish up. Day after tomorrow we'll finish up all these losses. So tomorrow I'll take 2:30 to 4:30. Okay. Day after tomorrow also 2:30 to 4:30. I'll try to finish as early as I can. So kindly cooperate with me till I complete the content. Okay. So now let us go back to again promotion. Sana Academy is offering 23% flat discount in the year 2023 on the eve of New Year. So grab this opportunity and subscribe and use my code GATECIVIL. Okay. So they're also conducting mock exam free of cost. You can enroll and they will announce you all India rank also. You can cross check and verify yourself where exactly you stand in the competition. Okay, so that you can fine tune your preparation. Okay. Unacademy owner in Tendulkar is partner. Same T-shirt. Okay. Feel free to ask any doubts. Don't hesitate. Subramaniam followed me. Subramaniam answered almost all of the questions. Thank you. Muthulakshmi Subramaniam. Very good. Are you from Tamil Nadu? Muthulakshmi? Good, Amma, good. Any doubts are there, you can ask me. Don't hesitate. You are most welcome. EMI options also available, you can avail. Thank you very much. So tomorrow again we'll meet at I'll announce timetable, but 2:30 to 4:30 tomorrow. Okay. Tomorrow we'll meet again at 2:30 to 4:30. We'll continue our discussion. Tomorrow's schedule. Do join me and learn from me. Useful to you, the last minute preparation this is. Okay then, all of you, namaskar. Okay, bye.